Hey, tonight we're exploring what happens when two galaxies collide. You picture the night sky as it is now, familiar stars scattered across a dark expanse. But in your mind, you let the view drift further, far beyond the constellations you recognize. Out there, in the quiet and unhurried depths, two great spirals are moving toward each other. They are so far away that their approach would look motionless to human eyes, yet you know the motion is there. It's a meeting not of minutes or even lifetimes, but of billions of years written into the architecture of the cosmos long before you were here to wonder about it. You probably won't survive this world unchanged, but that's the point. So before you get too comfortable, take a moment to like the video and subscribe, but only if you enjoy quiet stories like this. And if you're still awake after listening, write your location and local time in the comments. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The scene forms in your imagination. Two galaxies facing each other across a gulf of darkness. Each one is vast, 100,000 light-years across, filled with hundreds of billions of stars. They are not rushing but gliding, bound by gravity's invisible pull. You watch as the disks tilt and shimmer, spirals of light set against velvet black. There's no sound, no flash of warning, just the patient, inevitable drift. As you let the vision settle, you remember how distances in space bend the mind. A light year itself is almost impossible to hold in thought, nearly 10 trillion kilometers, and yet here you are, imagining structures 100,000 times larger. Even in this scale, the galaxies still appear fragile, like two pale seashells suspended in water, caught in a slow current that draws them closer together. The quietness deceives you. There's energy everywhere. Each star is like a furnace, burning for billions of years. Each cloud of hydrogen is dense with possibility. And in between them, the darkness isn't empty at all. It's a fabric laced with unseen matter, the scaffolding of the universe. You're watching not just two galaxies, but two whole ecosystems of stars, planets, dust, and black holes, all being nudged toward a future they cannot avoid. One quietly fascinating fact drifts into your awareness. Even though galaxies collide, their stars almost never touch. The reason is scale. Imagine 2 grains of sand separated by a kilometer, and you get a hint of how much space lies between stars. It's an eerie thought. Galaxies can pass through each other like ghosts, while their shapes distort in spectacular ways. You carry that image for a moment. Stars moving like lanterns on an invisible tide, swaying but not breaking. You wonder what it would look like if you stood on a planet inside one of those galaxies as the other approached. At first, it might appear only as a faint smear in the night sky. Over millions of years, it would swell until the heavens were full of light, a glowing arc across the firmament. Entire cultures might rise and fall under such skies, never realizing that the great cloud above them was another galaxy, inching closer with every passing generation. Researchers still wonder what emotional weight ancient beings might have placed on such visions. If our own Andromeda galaxy were already colliding with the Milky Way, humans would live beneath a sky transformed, streaked with flowing rivers of stars. Would that have changed history? Would religions, art, and myths have grown in different directions under such constant celestial reminders? It's a reflection you linger on, knowing that science deals in measurements, but people live in stories. The galaxies drift closer in your mind. Their edges begin to blur. Streams of stars tugged outward like wisps of smoke. You trace their arcs, delicate and uncertain. Nothing explodes yet, nothing shatters, but you sense the building tension. It's as if the universe holds its breath, waiting for the slow ballet to unfold. The spirals tilt again, one slightly above the other, like dancers circling before the first step. An unusual detail returns. This dance has happened countless times before. The elliptical galaxies you sometimes see in photographs, hazy, football-shaped clouds of light, are almost always the result of collisions long past. What you watch now isn't rare, but normal, one of the universe's most common transformations. Galaxies are not fixed monuments. They are rivers, forever reshaping, merging, flowing. You're not watching destruction, but evolution. Your thoughts drift back to scale, to time. A billion years feels meaningless compared to your own life, and yet it is precisely the unit the universe uses to write its stories. You are a brief flicker in a saga that stretches longer than imagination, but still, somehow, you are here, able to imagine it. That paradox, your smallness against the immensity, soothes you rather than troubles you. You feel less burdened by urgency, more at home in the slowness. As you rest in that feeling, you notice the galaxies again, now visibly distorted. Their cores brighten, their arms stretch. A hint of contact forms, though you know the stars are still drifting safely apart. The drama plays out in silence, a dream you can continue to follow. You let your breathing match the pace of the scene, slow, unhurried, infinite.
You drift deeper into the vision, carried along the dark corridors between the stars. The two galaxies are still approaching, though you know this approach is not sudden, but deliberate, stretched across unimaginable spans of time. What draws them together is not chance, not a whim, but the steady insistence of gravity's invisible threads. You cannot see them, but you feel them. They are the silent cords weaving the fabric of the cosmos, linking suns to planets, clusters to clusters, galaxies to galaxies. Without them, there would be no story here, only islands drifting apart forever. The galaxies stretch like two luminous whirlpools, each heavy with billions of stars. Between them hangs an unseen rope, a tension in the dark. You realize that gravity is not simply a force that pulls, it is also the sculptor of form, the choreographer of motion. Every curve of every spiral arm, every slow tilt of the disks, every ripple of dust is drawn by its hand. You picture the stars as beads on strings, all tugged subtly toward a new arrangement. It is calming to think that the universe holds together because of something you cannot see. Gravity is weaker than almost every other force you know, and yet because it acts on everything that has mass, it wins in the long run. It never sleeps, never fades, and never lets go. That persistence feels strangely reassuring. A quietly fascinating fact drifts into thought. In the 19th century, long before telescopes revealed colliding galaxies, a mathematician named Urbain Le Verrier discovered the planet Neptune without ever seeing it. He noticed that Uranus wobbled in its orbit, as if tugged by an unseen thread. By calculating where the hidden planet must be, he showed that gravity betrays the presence of things that cannot yet be observed. In the same way, astronomers today trace the motion of stars to discover not only the shapes of galaxies, but the invisible matter that binds them. You imagine floating between the two galaxies now, in a place without stars of its own. Around you, the darkness quivers with unseen lines of attraction. They stretch from core to core, from halo to halo, and they are tightening, drawing the two spirals toward a shared fate. You can almost sense their weight, though it is not weight you feel, but inevitability. The moment may not arrive for billions of years, but the outcome is certain. An eerie detail flickers in your mind. When galaxies are this close, they are not simply being pulled together. They are pulling each other apart. Stars on the outer edges may be drawn into vast arcs, stripped from their homes, wandering as intergalactic orphans. Some may travel forever, carried into deep space where no galaxy will claim them. These lonely suns will shine in isolation, for billions of years, lighting no skies, circling no centers, forgotten except in the faint tug they still exert across the void. You picture them, drifting like lost lanterns, and wonder if perhaps one of those stars might one day host planets, circling endlessly, with no great galaxy to belong to. It is a possibility both beautiful and unsettling. Researchers still wonder exactly how much of this invisible dance is governed by the galaxy's visible stars, and how much is controlled by the vast halos of dark matter around them. These halos, enormous and unseen, outweigh the stars and gas by far, but we cannot touch or measure them directly. They bend gravity like a lens, revealing themselves only through the way light curves as it passes. You reflect on this, that most of what decides the fate of galaxies cannot be seen, only felt. It's a reminder that mystery is not absence, but presence, waiting to be recognized. You watch the spirals again. Their edges blur, faint threads of starlight already beginning to stretch outward. Each line is a mark of gravity's script. The galaxies are no longer just approaching, they are speaking to each other, though the language is distortion and shape. And in this slow exchange, you realize you are not just an observer. By imagining it, you are part of it. Your mind's attention is one more connection across the abyss, however small. As you linger, you recall that your own body here on Earth is bound by the same threads. The ground beneath you holds you down, but it is also the planet's way of belonging to you. The sun holds the Earth, the galaxy holds the sun, and in a long chain of belonging, you are tethered to everything else. You are not outside this story, but woven into it, as surely as a star at the edge of a spiral arm. That thought relaxes you. It loosens the sense of separation, leaving you lighter, more at ease in the slowness of the cosmos. The galaxies hang suspended before you. They are still distant, still apart, but their motion is inevitable. You breathe in the stillness of this moment and let yourself trust the invisible threads that draw everything together.
The galaxies have drifted nearer now in your mind, and you begin to notice the subtle stretching of their luminous arms. What was once a clean spiral pattern starts to distort, like fabric pulled gently from its edges. You see streams of stars drawn outward, long, curving arcs trailing into the black. These are tidal tails, ribbons of light unraveling into space. They're beautiful, delicate, and strangely melancholy, as if the galaxies are shedding pieces of themselves to honor the meeting. You imagine following one of those tails, floating along its length. It may extend for hundreds of thousands of light years, longer than the galaxies themselves. Each speck you pass is a sun, some with planets, each system once comfortably anchored in the spiral disk. Now they are stretched thin, pulled into new orbits, perhaps never to return. The sight is serene, almost painterly. Luminous threads weaving patterns no human hand could ever create. A quietly fascinating fact arises as you drift. In 2007, astronomers discovered stars far beyond the Milky Way's visible disk, traveling at extraordinary speeds. They were called hypervelocity stars, ejected by gravitational interactions. Some may have been flung out by the tidal forces of ancient collisions. Imagine that. Suns themselves becoming travelers, cast adrift across intergalactic night. It gives you a sense that nothing in the universe is ever entirely still. You let your attention return to the galaxies. Their arms now look like outstretched fingers reaching toward each other. The stretch of starlight is not uniform. Some parts coil tightly, others unravel more freely, like ink dissolving in water. It is gravity, again, uneven and complex, pulling hardest where the mass is greatest, relaxing where there is emptiness. The result is asymmetry, a crooked, elegant distortion. You breathe it in as if watching a slow dance take form. An unusual detail flickers into awareness. These tidal tails sometimes contain enough gas and dust to form entirely new dwarf galaxies. Out of the torn edges, fresh islands of stars can condense, small but real, companions born of chaos. In this way, collisions do not only strip galaxies apart, they also seed new beginnings. You picture a small cluster of stars forming far from the cores, a lonely new world spiraling quietly on its own path. It feels like an echo of creation itself, hidden within the seeming ruin. You reflect on the beauty of unraveling. Humans often think of stretching or breaking as loss, but here it creates something spectacular. The galaxies become more intricate in collision than they were in solitude. Their shapes, once stable, now reveal hidden complexity. Perhaps that's true of you as well, that the moments when you are stretched thin reveal unexpected patterns, threads of yourself that shine against the dark. Researchers still wonder how predictable these tidal tails really are. Simulations on supercomputers recreate galactic collisions, showing arms bending and stars flowing outward. But the smallest differences in initial motion can create wildly different shapes. It's the sensitivity of chaos, written on a cosmic scale. This unpredictability reminds you that even when the laws of physics are clear, the exact outcome may remain unknowable. The galaxies are both determined and free, bound by gravity, yet improvising their dance. You close your eyes and let yourself drift in the slow pull of the scene. The stars stretch outward like strands of silver hair blown in windless air. You picture yourself suspended among them, your body quiet, your thoughts dissolving into the long arcs of light. It is not frightening to be so small within the scene. If anything, it is liberating. You belong to the pattern, and the pattern is endless. The galaxies have not yet collided fully, but already they are changed. Their arms no longer loop neatly, but extend like questions into the dark. And you, watching, feel the questions resonate in you. How much can be pulled away before the whole is lost? How much unraveling is necessary before something new can emerge? The answers remain just beyond your reach, and that's all right. In the silence of space, questions are their own kind of music. You let the tidal tails fade gently into distance, knowing they will continue to lengthen as the galaxies draw nearer still. The stretching of starlight is only the first whisper of what is to come.
You float closer now, letting your attention slip away from the graceful arcs of starlight and into the darker regions between. Within the galaxies, the true collisions are not of stars, but of gas and dust. Clouds vast enough to dwarf your imagination drift through the spiral arms, heavy with hydrogen, cooled over millions of years. When galaxies near one another, these clouds no longer pass silently by. Instead, they meet, compress, and churn. It is here that the silent chaos begins. You picture it, two invisible rivers colliding head-on, their waves crashing, not with sound, but with pressure. Where streams of gas meet, shock waves ripple, compressing the matter into dense knots. Temperatures climb, molecules vibrate, magnetic fields twist. The calm appearance of the galaxies from afar hides this storm, like a painting concealing the frenzy of brushstrokes behind its stillness. The deeper you drift into the clouds, the more you feel the contradiction. Quiet in scale, violence in detail. A quietly fascinating fact comes to you. These gas clouds, often called giant molecular clouds, can span over 100 light-years and weigh millions of times more than the Sun. Entire star clusters are born within them. The collisions of galaxies stir them like spoons in cosmic oceans, triggering waves of formation. In this way, the chaos is creative, destruction leading directly to birth. You drift deeper still, into the hazy folds of one cloud. The darkness thickens, pierced only by faint glows of ionized gas. You imagine the atoms themselves pressed together, forced into intimacy by the gravitational shoving of galaxies. It is a strange intimacy, silent and cold, yet pregnant with light. Soon enough, these clouds will break open with stars, but for now, you linger in the in-between, in the stillness before the spark. An unusual detail drifts across your awareness. Some of these clouds, when compressed too quickly, may form not only stars, but entire structures of turbulence that mimic storms on Earth. Astronomers have compared the flows of interstellar gas to hurricanes, twisting and rotating with chaotic spirals. Imagine a storm so large it could swallow the solar system whole, and yet so diffuse that a spaceship could pass through without ever touching a raindrop. It is chaos hidden behind transparency, as if the air itself had chosen to rage without ever being seen. You pause here, letting the thought settle. It reminds you that most turmoil, even in your own life, is not always visible from outside. Clouds can look calm until stirred, and so can people. Yet within that stirring lies the potential for change, sometimes painful, sometimes luminous. Researchers still wonder exactly how these turbulent interactions regulate star formation. Do collisions always ignite new suns, or do they sometimes smother them? Observations show both. In some regions, bursts of stars explode into being, while in others, clouds collapse too chaotically, dispersing before anything can form. The balance remains uncertain, and in that uncertainty, you find comfort. Not every disturbance must follow the same rule. Some storms end in stillness, some in fire. You let your imagination widen, pulling back slightly to see the galaxies again, but this time through the lens of gas rather than stars. Where the spirals overlap, great rivers of dust interlace, glowing faintly in infrared light. If you could hear them, you might imagine a low hum, the murmur of molecules colliding. But there is no sound here, only the impression of pressure. The silence deepens as you drift along, the storms unfolding slowly beneath you. You notice how fragile the structures appear, wisps unraveling, filaments bending, and yet they carry the seeds of entire suns. Something about that contrast stays with you, fragile but powerful, chaotic but generative. You close your eyes in this vision, letting yourself feel like one of the drifting particles in the cloud. You have no sharp edges, no urgent tasks, just the slow bumping against neighbors, the gentle push and pull. It is strange, but the thought relaxes you.
You imagine dissolving into the cloud itself, part of the silent chaos, waiting without hurry for the spark that may or may not come. The galaxies continue their slow embrace outside. Their spirals distort further, and the clouds within them keep colliding, reshaping, pressing onward toward the next stage. You remain in the stillness, letting the storm carry you deeper into its quiet center.
You follow the thought of two galaxies as they drift into each other's gravity, and something delicate begins to unfold. The vast disks, each with billions of stars, do not simply merge like two stones dropped into a pond. Instead, their spiral arms stretch, fin, and trail behind them like silk scarves caught in invisible wind. These long ribbons are called tidal tails, and you imagine them extending across hundreds of thousands of light years, glowing faintly with scattered starlight. They are fragile, almost ephemeral, and yet they carry entire star clusters within them. You picture yourself drifting along one of these streams. There is no up or down, no horizon to break the stillness, just a faint, diffuse band of stars curling like smoke in the dark. The stars are not colliding here. Instead, they are being tugged, one by one, their orbits slightly altered by the combined pull of both galaxies. It is like watching dancers step out of rhythm, but still holding the thread of the music. A quietly fascinating fact rests in this image. Some of the brightest star clusters ever observed were born in these tidal tails. When gas clouds are pulled outward, compressed by tidal forces, they collapse into brilliant knots of newborn stars. Astronomers have found superstar clusters, thousands of times more luminous than typical open clusters, living in these faint tails. Entire generations of suns are born in the wake of destruction, as if chaos itself plants seeds of creation. As you float further along, you notice that these tails are not symmetrical. One might curl outward like a graceful arm, while the other whips backward like a loose ribbon. This asymmetry carries a clue. It depends on the angle and speed of the galactic approach. Sometimes tails wrap around each other in loops, creating shapes that resemble shells or rings. To telescopes on Earth, these patterns look almost like cosmic brushstrokes, nature painting arcs across space. An eerie detail lingers. If you were standing on a planet within one of these tails, the night sky would never be the same again. Entire constellations would seem to unravel over millions of years, stretching longer, pulling apart, fading into new alignments. It would be a slow distortion, too subtle to notice in a single lifetime, yet relentless over epochs. A civilization might record myths of stars that slowly wander away, as though the heavens themselves were restless. And there is the open-ended reflection. Scientists still debate how long these tidal tails endure. Do they dissolve back into the galaxies after the merger, or do they survive as faint streams, like fossil trails across the cosmic background? Some simulations suggest that stars in the longest tails may drift away permanently, becoming orphaned wanderers between galaxies. Others may loop back, falling into the remnant core after billions of years. No one is certain. The universe doesn't reveal its timing easily. You imagine these orphaned stars, drifting without a galaxy to call home, alone, yet not extinguished, still burning quietly for billions of years. They carry with them the memory of a collision long past, like messengers carrying secrets through the void. Perhaps one of those stars could host a planet, and on that planet, life might someday look up at a sky where no galaxy dominates, just a sparse sprinkling of lonely suns. A sky that feels empty, but also deeply peaceful.
Back in your mind's eye, you trace the movement of stars as they are drawn outward. They arc slowly, so slowly that even light takes millions of years to trace their path. Yet when astronomers run simulations on their computers, the process looks almost fluid, sped up into a graceful dance. Watching it, you feel both comforted and unsettled. Comforted by the beauty of the flow, unsettled by how fragile structure becomes when nudged by gravity on such scales. The tidal tales also whisper about time itself. These streams may last for 1 billion years, but compared to the age of the universe, even they will fade. The stars will scatter, the light will dim, and only careful observers will ever know they were once part of something larger. It is like the remnants of a melody you can almost remember, but not quite. You let your thoughts drift further. What does it mean to belong to a structure and then to be pulled away? To be part of a galaxy and then exiled into the quiet of intergalactic space? Maybe it mirrors something human. The way memories stretch and fade, the way connections sometimes loosen over time. Just as stars in a tidal tale still shine even when far from the galactic core, perhaps people carry their own light even when distance grows. A final thought drifts into view. When we look at the antennae galaxies, two spirals colliding just 45 million light-years away, we are seeing tidal tales in action. Long arcs of starlight, faint but unmistakable, curving outward like insect antennae. They are proof that what you've been imagining is real. Yet what you see through a telescope is also ancient, light that left those galaxies before humanity even walked the Earth. The tales are there, unfolding whether you witness them or not. And so you breathe slower, imagining yourself carried gently along one of those ribbons of stars, with nothing pulling you except the invisible tide of gravity. You drift without hurry, knowing that time itself bends here, stretched as thin and delicate as the tales you travel through.
You stay with the vision of those long tidal tales, and then your attention turns inward, back toward the crowded hearts of the colliding galaxies. If the outer ribbons are stretched into graceful arcs, the centers are turbulent seas where stars churn through distorted orbits. You wonder what happens to those suns, to the fragile worlds that may circle them, when two galaxies entangle. The question hangs in the stillness. Does everything end in fire, or is survival more common than you'd think? Here is a quietly fascinating fact. The vast gulfs between stars are so immense that direct collisions are incredibly rare. Even in the densest galactic centers, the average distance between stars is measured in light years. Imagine two fireflies trying to collide in a stadium. The chance is small. So when galaxies merge, the stars mostly pass by each other like ghosts, tugged by gravity, but seldom colliding. The galaxies may look violent from a distance, but the stars themselves often glide unharmed. And yet, safety is relative, because gravity reshuffles everything. Stars are thrown into new orbits, some flung outward toward intergalactic space, others drawn closer to the remnant core. Entire solar systems may be stretched, tilted, or even stripped of their planets. If you picture yourself on a world orbiting one such star, you might feel the slow disquiet of your night sky changing. Familiar constellations could bend, twist, or vanish altogether, as the stars around you migrate under unseen forces. The process would be so slow that you'd never notice in a lifetime. But over millennia, the heavens would shift like a great map being redrawn. There is also an eerie detail here. Though stars rarely collide, gas clouds do. They crash, compress, and ignite furious bursts of star formation.
If your world lay too close to such a region, the night sky would blaze with new suns, some massive and short-lived, destined to explode as supernovae. A nearby supernova could bathe your planet in lethal radiation, stripping atmospheres, altering biology, leaving only silence. So while most stars glide peacefully, pockets of chaos bloom, and survival becomes a matter of distance and chance. Astronomers simulate these mergers and watch the stars scatter across their screens. They see patterns of slingshot motions, where one star is hurled out at immense speed, what they call a hypervelocity star. Such stars can leave their galaxy entirely, racing into the dark between islands of light. You imagine riding along with one, carried far from its birthplace, a solitary traveler fleeing the chaos behind. What kind of night sky would you see then? Perhaps nothing but blackness and the faint glow of your old galaxy dwindling into a blur. Here lies the reflection. If survival depends on distance, then what does it mean to be lucky in a universe without intention? Your star, your world, might remain in a quiet orbit, untouched for billions of years. Or it might be swept into the storm, cast into radiation or darkness. Researchers still wonder how many planetary systems survive mergers intact. Some simulations suggest most endure, shifting orbits but not destruction. Others propose that many planets are destabilized, flung into deep space as frozen rogues. The truth is uncertain, hidden in the enormity of cosmic time. You let your thoughts follow a more personal path. What would it be like to look up and see two galactic cores drawing closer in your sky? Bright knots of millions of stars, glowing like twin suns on a grand scale. At first, just faint smudges. Then, across millennia, brighter, more detailed, their arms beginning to overlap. Entire civilizations might rise and fall beneath such a sky, passing down myths of approaching light, wondering if it means the end or a beginning. You pause on another quietly unsettling fact. Even if a planetary system survives gravitational reshuffling, its long-term climate may not. If your star is dragged into a new orbit closer to the galactic center, you could find your sky lit by more frequent supernovae, gamma-ray bursts, and radiation storms. Move too far outward, and your world might lose access to the raw materials, cosmic rays, heavy elements, that foster planetary chemistry. Survival is not just about not being destroyed. It is about continuing to exist in a balance that allows life to thrive. And so, in the stillness of this thought, you consider that survival may not be permanent. Nothing in the universe holds still forever. Orbits shift, stars evolve, galaxies merge and reshape. Even the most stable-seeming system is only temporarily safe, its peace measured against billions of years of change. Perhaps in that sense, we live always in tidal tales of time, pulled slowly by forces larger than ourselves, unaware of how far we have already drifted. The open-ended question remains. If galaxies have collided countless times across the universe, how many civilizations were disrupted or extinguished before they could even wonder about their fate? And if others survived, what did their myths tell them, watching galaxies grow bright in their skies? Did they fear? Did they celebrate? Or did they simply look upward, as you do now, and feel small, yet comforted by the quiet inevitability of cosmic change? And so you linger here, imagining yourself on a world that endures, circling a star that slides gracefully through the storm. Your sky changes, but you adapt. You live your days under shifting constellations, unaware of the grand dance reshaping the heavens. Life continues, even when galaxies collide.
You hold on to the image of surviving stars and altered skies, and now your focus drifts toward the hearts of these merging galaxies. Their centers are not just clusters of stars, they are anchored by colossal engines, supermassive black holes. Every large galaxy we know seems to cradle one, millions or even billions of times heavier than our Sun. And when two galaxies collide, so too must their black holes. You imagine what it feels like, drifting ever closer to one of these titans. At first, nothing appears unusual. The stars still shine, the gas still glows, and the black hole itself remains invisible. Yet the deeper you float, the more space begins to curve around you, light bending, paths twisting, like water swirling toward a drain. Your mind rests on the idea that these invisible objects control the fates of entire galaxies. They are silent, patient, but relentless. A quietly fascinating fact surfaces. When two supermassive black holes spiral toward each other, they do not collide instantly. Instead, they orbit for millions of years, slowly losing energy through gravitational waves, ripples in space-time itself. Detectors on Earth, like LIGO and Virgo, have already recorded such ripples from smaller black holes. Someday, perhaps, we may hear the low, thunderous hum of galactic giants merging, a cosmic bass note resonating across billions of light years. Yet there is also an eerie detail. Before merging, these supermassive black holes may unleash violent activity. As gas is drawn inward, it heats up, forming bright accretion disks and jets that fire across space. To an observer, the night sky could bloom with sudden brilliance, as if a second quasar had awakened overhead. Imagine living on a world orbiting quietly in one galaxy, and then, over ages, watching your skies flare with light so intense it outshines all the stars combined. Your civilization would see a beacon of destruction and creation far beyond your reach. Researchers still wonder about the exact mechanics of these mergers. Do the black holes always sink to the center, or can one be slingshotted away, ejected at thousands of kilometers per second, carrying its surrounding stars like a small galaxy of its own? Some simulations suggest entire black holes may become wanderers, drifting between galaxies, dragging faint stellar companions like a forgotten caravan across the void. If so, there may be black holes wandering out there now, dark monarchs ruling invisible kingdoms. You let your thoughts settle on the scale of it all. These black holes are silent collectors, their appetite never satisfied. And yet without them, galaxies themselves might not exist. Their gravity stabilizes galactic cores. Their feedback regulates star formation. Too violent, and galaxies strip bare. Too quiet, and galaxies may collapse inward. It is a delicate balance, one that echoes in your own body. Too much order, and life cannot change. Too much chaos, and it cannot endure. In the dreamlike quiet, you imagine yourself floating near the horizon of one of these giants, where time itself stretches. If you looked outward, you might see the colliding galaxies racing through their merger. But if someone far away looked at you, they would see you frozen, never quite falling in. The merger would complete, the galaxies would settle, and you would still appear to linger at the edge of the abyss. It is a reminder that perspective is everything, even in cosmic events. The reflection deepens. If black holes are the inevitable end for stars, and if galaxies themselves funnel into these singular hearts, does the universe always trend toward collapse? Or is there renewal hidden even here? Some theories suggest that when black holes merge, they radiate enormous energy outward, waves that may help shape structure across the cosmos. Destruction feeding creation, again and again, in rhythms we can barely glimpse. Your mind wanders to a curious piece of history. In 1916, Einstein first predicted gravitational waves. He thought they might never be detected, that the ripples of space-time were too faint. A century later, humanity built instruments sensitive enough to measure distortions smaller than a proton,
catching signals from black holes colliding billions of years ago. You realize, with quiet awe, that as you drift in this imagined space, your own species has already begun to hear the music of the universe, faint but undeniable. The eerie possibility returns. Somewhere, two supermassive black holes may already be spiraling together, unseen. Their final embrace will unleash more power than all the stars of their galaxies combined, in a moment briefer than a blink. And though the light may never reach us, the waves will. We may feel them ripple through the ground beneath our feet, a whisper from an event across unimaginable distance. You settle into this thought, carried by the rhythm of inevitability. Just as galaxies must merge, so too must their hearts. And though the process is violent, the universe does not hurry. It unfolds over millions of years, slow enough for life to rise, to wonder, to sleep beneath shifting skies.
You linger near those immense black holes, feeling the slow spiral of inevitability. But your focus drifts outward again, to the vast clouds of dust and gas scattered through the merging galaxies. For though black holes shape the centers, it is these clouds, the raw material of stars, that decide what the new galaxy will become. And when galaxies collide, those clouds rarely remain quiet. They crash into each other, compress, and collapse. The result is something both violent and beautiful, a starburst. You imagine the scene gently, as though seen through a veil. Enormous molecular clouds, each dozens or even hundreds of light years across, drift into contact. Instead of slipping past like stars, they slam together, their gas compressed into denser knots. In these knots, gravity tightens its grip, drawing hydrogen atoms closer until fusion ignites. A flood of new stars is born, not one at a time, but by the thousands, like fireworks set off in slow motion across the galactic canvas. Here is a quietly fascinating fact. In a starburst phase, a galaxy can form stars at a rate hundreds of times greater than normal. The antenna galaxies, for example, are creating so many new suns that their combined glow outshines entire regions of the sky. If you could hover nearby, the view would not be of ruin, but of astonishing renewal, as if the galaxies are not dying, but giving birth to something grander. And yet, there is an eerie detail hidden within this beauty. Many of these newborn stars are massive and unstable. They burn with fierce intensity, their lives measured not in billions of years like our sun, but in mere millions. Such stars end in spectacular explosions, supernovae, that ripple through their surroundings. A starburst galaxy may therefore shine brilliantly, but it also seeds its own destruction, filling space with shock waves, black holes, and neutron stars. Creation and annihilation unfold side by side, inseparable. You pause to consider what this means for any fragile worlds within such a galaxy. If your planet orbited a calm star, tucked away from the chaos, you might watch your night sky fill with unfamiliar brilliance. New stars would bloom like lanterns, constellations reshaping themselves. But if you lived too close to the starburst regions, the constant storms of radiation could strip your world bare. Life would not flourish easily in such an environment. Survival would depend on distance, shielding, and luck. Researchers still debate how long starbursts last. Some estimates suggest they burn out within a few 100 million years, exhausting the available gas. Others propose that the process ebbs and flows, regulated by the very supernovae that starbursts create. Explosions can blast gas outward, halting star formation for a while, until gravity pulls it back in. The cycle may repeat, like a galaxy breathing. Inhale, exhale, over cosmic time. Your mind drifts toward another image, star clusters forming in the tidal tails, far from the galactic centers. These clusters, packed with newborn stars, may survive the merger as independent systems. Some may even escape the galaxy entirely, wandering the universe as globular clusters, fossils of a long-ago collision. If you were to visit one, you would find yourself surrounded by thousands of suns crowded into a tiny region, your sky ablaze with starlight on every horizon. The reflection deepens. You realize that the universe does not separate creation from destruction as neatly as we do. A galaxy collision is both. It is death for some stars, rebirth for others. It is loss of old patterns and birth of new ones. Perhaps your own life carries echoes of this, moments where endings and beginnings arrive together, inseparable, two sides of the same transformation. There is also a curious piece of history to hold here. In the 20th century, astronomers first began to notice galaxies with peculiar shapes, long tails, twisted arms, unusual brightness. Some dismissed them as oddities. But as telescopes grew sharper, the truth emerged. These were galaxies in the throes of collision, their shapes sculpted by gravity and their light amplified by starbursts. What once seemed rare turned out to be common. The universe, it seems, is littered with collisions, and starbursts may be one of the main engines of galactic evolution. And so you let yourself float in the midst of it. Around you, clouds collide, new suns ignite, and the void fills with the glow of creation. It is noisy in theory, shock waves, radiation, turbulence, but in your mind it is silent, a slow blossoming of light in the darkness. You drift past nursery after nursery, each one a cradle of possibility. Somewhere, new worlds will form, circling new stars, and on some of those worlds, perhaps, life will awaken, look upward, and wonder what came before. You breathe softly, imagining those future skies. A civilization might grow on a planet born of colliding clouds, never knowing their galaxy was once two. For them, the night would be filled with beauty, a quiet inheritance of violence long past. They would build their myths beneath unfamiliar constellations, unaware of the ancient dance that gave them their stars. And perhaps like you, they would find comfort in the thought that even in destruction, the universe is patient, endlessly renewing itself.
Close your eyes and imagine once more the two galaxies we've been following. You've seen them from afar, sweeping across cosmic time like dancers in an endless ballet. You've drifted through their spiral arms. You've hovered among the starbursts, and you've watched them bend and warp under each other's pull. But now, let's draw back, further and further still, past the swirls of dust, past the glowing knots of gas, past the sharp arcs of tidal tails that stretch like ribbons of light into the void. From this distance, you see something almost unbelievable. The galaxies are not isolated curiosities. They are part of a much larger, flowing ocean of matter, where everything moves, where nothing is truly still. The universe itself is in motion. If you linger on this thought, you notice how strange it is. Here on Earth, motion is something you compare against the ground, against the sea, against the air. But out here, there is no ground, no universal reference point. Everything moves relative to everything else. The two colliding galaxies are drifting toward each other, yes, but their dance is only one small current in a cosmic sea of motions. Clusters of galaxies are sliding through space, drawn together into filaments that stretch across hundreds of millions of light years. Those filaments, too, are moving, shaped by gravity like rivers carving valleys into stone. And behind all this,
Beneath all this, space itself is stretching. The very fabric on which galaxies are arranged is pulling outward. It is as if you were watching not just dancers twirling on a stage, but the stage itself swelling, expanding, carrying the dancers apart, even as they spin toward one another. How do collisions happen at all, you might wonder, if the universe is expanding? The answer lies in balance. On the grandest scale, galaxies drift apart with the stretching of space. But in local pockets, gravity wins. Gravity binds galaxies into clusters, clusters into superclusters, and within those groups, collisions are inevitable. The universe grows larger, yet still, galaxies fall together. You might now imagine the Milky Way and Andromeda locked in their quiet, inevitable spiral toward one another. Their mutual pull is stronger than the outward tug of cosmic expansion. In about 4 billion years, they will meet. Not because space shrank, not because the universe reversed, but because their gravity whispered louder than the expansion's call. This is how motion feels on the cosmic scale. An endless tug of war, a balance between stretching outward and pulling inward. Galaxies obey this balance, caught in orbits, falls and collisions that take billions of years to unfold. Let's return to our colliding pair. By now, perhaps they have passed through one another once, their stars mostly untouched, their gas clouds shaken and torn, their spiral arms flung into arcs like long glowing tails. In time, they will pass again. Each encounter slows them down, binding them tighter, until at last they settle. The motions smooth out, the chaotic swirls calm, and from two spirals emerges a single, rounded galaxy. You watch this process unfold not in seconds, but in eons. The patience of the universe is infinite. It never rushes. The motions of galaxies resemble breathing, slow, steady, cyclical. Inhale as they draw close. Exhale as they drift apart. Inhale again until finally they rest together. And then your mind drifts further still. What of all the other galaxies? Billions of them, each with its own path, its own neighbors, its own collisions waiting to happen. From a distance, the universe looks alive, like a living tissue, where galaxies are its cells, migrating, merging, sometimes consumed, sometimes reborn. It is not a violent chaos, though. It is more like the flow of tides or the unfolding of a cloud. Gentle, inevitable, strangely soothing. When galaxies collide, they are not ending. They are transforming, shifting into new forms, carrying forward the legacy of stars and worlds that may one day shine again. You might wonder, if everything is in motion, if nothing stands still, then what about you? Here you are, drifting in thought, picturing scales so vast they stretch imagination itself. And yet even you are part of this motion. Your planet spins. Your solar system circles the galaxy. Your galaxy itself is flying through space, drawn toward clusters, filaments, unseen attractors far away. You are carried along with it, a passenger in a universe that never pauses. And there is something comforting in this realization that stillness is only an illusion, that even when you are at rest, you are moving, swept up in the quiet rhythm of galaxies, stars, and the expanding fabric of reality itself. The two galaxies you have been watching are not unique. They are simply one story among countless others.
But by following them, you glimpse the larger truth that the universe is motion, that creation and destruction are the same process, that endings are beginnings written across billions of light years in trails of starlight. And as you drift further into this thought, you feel the rhythm of it settling into you, like the rise and fall of breath, like the beating of a slow, steady heart. The universe moves, and you move with it, always.
You have seen galaxies twist and stretch, merge and reshape. But now, let's move closer. Not to the whole of a galaxy, not to the graceful arcs of tidal tails, but to the smaller pieces that live inside, the stars, the gas clouds, and the fragile systems of planets that circle them. For when galaxies collide, these are the actors who feel the tug most directly. Not in the form of violent crashes. Stars are so far apart that even in the densest regions they rarely collide with one another. Instead, it is the space between stars that feels the greatest upheaval. Gas clouds, dust lanes, streams of invisible dark matter. These are stirred and shaken, compressed and stretched, setting into motion the forces that determine the future of stars and worlds. Picture yourself hovering near a star like the sun. Around it, faint rings of dust spiral gently, forming the birthplace of planets. Farther out, frozen bodies drift in the cold, waiting quietly in their orbits. Now imagine the pull of a passing galaxy sweeping near. The gravity does not slam into the star, nor does it fling the planets like stones. Instead, it changes the background field, nudging the star and its companions into new paths, like a ripple in a pond shifting the boats that rest upon it. Most stars survive the encounter. Their planets remain bound, though their orbits may stretch, tilt, or drift over cosmic time. But not all systems are so fortunate. Some stars, especially those on the outer edges of galaxies, may be cast adrift, flung into intergalactic space, becoming wanderers in the void. Others may be drawn into the new galaxy's core, where dense gravitational tides distort their once stable homes. But the gas clouds, though, are another story. Unlike stars, gas does collide. When galaxies meet, their great reservoirs of hydrogen and helium slam together, piling up like waves against a shore. The compression squeezes the clouds, forcing them to collapse, birthing storms of star formation. Entire regions ignite in starbursts, blazing factories of newborn suns. From afar, these appear as brilliant knots of blue light scattered along the arms of colliding galaxies. But if you drift closer, you would see a frenzy of creation. Clouds crumbling into clusters, sparks of fusion flaring to life, new stars outshining their parents, briefly, before burning fast and bright. In a single galactic collision, billions of new stars may be born. It is not destruction then, but renewal, a cosmic garden where collisions plant seeds of light that will shine for billions of years. And what of worlds? This is harder to imagine, for planets are small, fragile things. Most of them will never know their galaxy has collided at all. Their suns will keep burning, their orbits will keep turning, oblivious to the reshaping of the grand structure around them. But for a few, the fate is more dramatic. If their star is thrown outward, they may find themselves in the cold gulf between galaxies,
their skies empty of the crowded stars they once knew. They would orbit in silence, their night skies so dark that only distant clusters faintly glow. Other worlds may be drawn closer to the galactic core, into regions dense with stars where encounters grow more likely. Perhaps a passing star nudges their orbit, pulling them slightly, enough to change climates, tides, seasons. Perhaps two stars draw near enough that their planetary systems mix, scattering worlds like marbles spilled across a floor. These are rare events, yes, but they are possible, and in the vast span of time, even rare events must unfold. You might wonder, could such collisions threaten life? If there are civilizations somewhere among the stars, what would they see? What would they feel when their galaxies collide? At first, nothing. Generations would pass without noticing. The stars are so far apart that collisions unfold far more slowly than the rise and fall of species, of nations, of entire histories. But across millennia, the night sky would change. Faint smudges of light would grow brighter, resolving into spirals, arcs, and streams. Eventually, whole cascades of stars would cross their heavens until the night became a tapestry alive with motion. For such beings, the collision would not be catastrophe, it would be spectacle. A reminder that they live in a universe that breathes and changes on scales too vast for any single life to measure. As you drift through this thought, you begin to realize something subtle. Galactic collisions are not about endings. They are about transformation. The stars endure. The planets endure. And even when some are lost, scattered into the dark, others are born, carried in the light of new suns that blaze out of compressed clouds. The universe has no waste. Every collapse is followed by creation. Every upheaval is balanced by renewal. It is a cycle, endless and patient. And you, in your smallness, are part of it. Your atoms were once inside stars that formed from collisions of gas stirred by earlier mergers of galaxies long forgotten. The calcium in your bones, the iron in your blood, they are records of these grand encounters written in the quiet language of matter. So when galaxies collide, stars may shift, worlds may wander, gas clouds may blaze into storms of light, but the deeper story is one of continuity. Nothing truly vanishes. It only changes form, changes place, becomes a part of a larger pattern. And if you let that thought sink in, it feels like a kind of peace, a stillness beneath all motion, a reassurance that even in collision, even in chaos, the universe is not breaking, it is simply becoming something new.
You have seen the stars, the gas clouds, the fragile planets, each responding in its own way to the vast encounter of galaxies. Now turn your attention to something darker. Not the luminous arcs or the glowing nurseries of newborn suns, but the hidden centers, the black holes that sit at the heart of galaxies, waiting with unimaginable gravity. Every large galaxy, perhaps every one you can see, holds such a black hole. They are not ordinary in scale. The one at the center of your own Milky Way is 4 million times the mass of the Sun, yet it hides in silence, cloaked in darkness. In larger galaxies, they may reach billions of solar masses, objects so heavy that not even light can escape their pull. When galaxies collide, so do these black holes. Not immediately,
First, they spiral toward each other, tugged closer by the swirl of surrounding stars. It is a courtship measured not in years or centuries, but in millions of years. Slow, patient, inevitable. Imagine floating far above the mergent cores of two galaxies. Below you, rivers of stars stream inward, drawn by the deepening wells of gravity. The black holes are hidden, invisible, yet their influence is everywhere. They stir the orbits of stars. They twist the flow of gas. They bend the very shape of space. At first, they circle each other from a distance, each surrounded by its own cloud of stars. Gradually, friction from those stars, gravitational tug and scatter, slows their motion, drawing them inward. The spiral tightens. What began as two distinct centers becomes a single, restless core. In time, the two black holes reach a stage called a binary. They orbit each other directly, two voids locked in a gravitational embrace. Their dance is quiet but powerful, sending out ripples in space-time, gravitational waves, faint echoes that race across the universe. Einstein predicted them a century ago, and now instruments on Earth have caught their passing. Not from galaxies colliding nearby, but from other cosmic unions of black holes, smaller ones formed from stars. Still, the principle is the same. Two heavy masses, spiraling together, disturbing the fabric of reality itself. For supermassive black holes, the waves are deeper, slower, more sonorous. You could almost imagine them as music, notes so low that they take millions of years to complete a cycle, vibrations you cannot hear, but the universe does. Astronomers are only beginning to detect these background murmurs, this deep cosmic hum. And then, after an eternity, the spiral closes. The black holes merge. In a final burst of gravitational energy, the last orbit collapses, and what was two becomes one. The new black hole settles, larger, heavier, often with a spin imparted by the angled collision. Sometimes the recoil from the merger is so strong that the black hole is kicked away from the center, shot like a cannonball through its galaxy. Imagine a black hole millions of suns heavy, drifting alone, dragging its cloak of stars along as it wanders. No light marks its path, only its gravity does. Astronomers suspect such rogue giants exist, though proof is hard to catch. From afar, the merging of black holes is invisible. You would see the galaxies combine. You would watch stars swirl and gas ignite. But the black holes remain hidden. Their drama is silent, their violence cloaked. Only by studying the motion of stars and gas near the core can astronomers guess at what unfolds. Yet their role is immense. The merging black hole often flares into activity, feeding on the gas funneled inward by the collision. As matter swirls down its maw, it heats and glows, outshining the galaxy itself. Jets of plasma may fire outward, piercing thousands of light years, spearing the darkness with thin, radiant beams. Such galaxies become quasars, cosmic beacons seeing across the universe. You might wonder what it would look like to stand on a world near such a scene. Would the sky blaze with new lights? Would the darkness itself seem alive? Perhaps. If your planet orbited close to the center, the glare of an active black hole would flood your skies. Radiation would spill across your world, fierce and deadly. But farther out, you might see only beauty. Jets cutting the sky, clouds glowing, stars forming in cascades. It would be dangerous, yes, but breathtaking. The eerie thought is this: these colossal mergers, hidden and silent, shape galaxies more than almost anything else. They stir the orbits of millions of stars. They ignite quasars that sculpt whole clusters.
They may even control how galaxies grow by heating and scattering gas, preventing too many new stars from forming. Without them, galaxies might look very different. The night sky, even your own, would not be the same. Researchers still wonder how common these mergers are and how often they ignite the hearts of galaxies into blazing quasars. They wonder how many rogue black holes drift the void, unseen. And they wonder if far in the future, the Milky Way's black hole will meet its twin from Andromeda, spiraling for millions of years before merging into a single, silent giant. When you let that image settle, it feels less like doom and more like inevitability. The universe does not resist such unions. It waits for them. It lets them happen slowly, carefully, almost tenderly, until all that remains is one. So the fate of colliding galaxies is not written only in the arcs of stars or the birth of suns, but in the dark centers where black holes drift. They are the unseen choreographers guiding the final steps of the cosmic dance. And even though you cannot see them, you can almost feel their gravity tugging at your imagination, pulling you closer, whispering of endings that are also beginnings.
The galaxies have clashed, their stars pulled into spirals, their gas clouds compressed into storms of fire, their black holes drawn together in patient, invisible spirals. The chaos has unfolded over billions of years, long enough for entire civilizations to rise and fall, long enough for oceans to dry and mountains to erode, long enough that, to any one species, it might seem eternal. But even the greatest upheavals settle. And so, after the storm of collision, there comes a deep and lasting calm. Imagine yourself floating at the edge of this new merged galaxy. The arcs and tails that once stretched outward have thinned, their stars dispersed across space. The luminous knots of newborn suns still shine, but with less frenzy now. The jets of quasars fade as the central black hole exhausts its meal and returns to silence. The galaxy you see is different than either of the parents, no longer a spiral with elegant arms, nor a barred disk spinning gracefully. Instead, it is a vast elliptical form, round, smooth, featureless from afar, like a pearl suspended in the dark. This is the typical fate of colliding spirals. What was once a disk becomes a sphere of stars, their orbits randomized, their ordered motion lost in the tumbling chaos of the merger. The structure has changed, but the beauty remains, perhaps subtler now, a quiet glow instead of a restless whirl. In this calm, star formation slows. Most of the gas that fueled new suns has been spent, consumed in the starburst that the collision ignited. What remains is thin, diffuse, stretched across too wide a space to collapse again. The galaxy, once a nursery, has grown quiet. It is still full of stars, but they are older, redder, slower burning. The blue brilliance of youth gives way to the softer hues of age. If you drift among these stars, you might notice how evenly they spread, like dust motes in a beam of light. There are no arms to guide them, no spiral patterns to trace. Instead, they follow paths in all directions, weaving through each other, without ever colliding, kept apart by the vastness of space. It is a quieter dance, but no less intricate. Each star carries its own system, its own history, its own silent companions of planets, comets, and moons. Each continues mostly undisturbed, their private stories unfolding as the galaxy settles into its new identity. There is something almost melancholy about this stage. It is the aftermath of a drama, the hush after music fades, the long exhale after a storm passes.
And yet, it is not an ending. It is simply another state of being. Elliptical galaxies dominate the centers of clusters where mergers are most common. They are the elders of the cosmos, massive, round, filled with ancient stars. They shine with a softer light, but their presence is immense, their weight undeniable. Perhaps as you drift here, you feel the age of the universe pressing gently against you. You realize that collisions are not rare accidents, but part of the natural rhythm of growth. Galaxies live, they change, they combine, they rest. The story is not destruction, but maturation. Astronomers wonder what becomes of life in such a galaxy. If worlds once circled in the spiral arms, basking in the steady glow of young stars, how do they fare when the gas is gone, when new suns no longer form? Some say life has less chance to arise in ellipticals, for without fresh stars and planets, the opportunities diminish. Others argue that the abundance of long-lived stars offers stability, quiet homes where life can endure for trillions of years long after brighter galaxies have burned themselves out. The debate remains open, like so much in the study of the universe. But as you listen to these possibilities, you realize something simple. Whether life thrives or fades, whether stars burn blue or red, whether galaxies whirl in spirals or settle in spheres, the universe continues. It does not ask permission. It does not seek approval. It only flows. You might think back to the beginning of this imagined journey. You were looking at two separate galaxies, majestic, distant, each complete in its own way. Now they have become one, inseparable, their boundaries erased. If you had not witnessed the process, you would never know they were once apart. You would only see the new whole, the single luminous presence in the dark. That is how time works on scales like these. It softens memory, erases detail, leaves only the enduring. The chaos fades. The calm remains. From your vantage, far at the edge of this new merged galaxy, you feel the silence settle. No explosions, no great arcs of motion, only the steady light of countless stars drifting together through the dark. It is a scene both vast and intimate, as though you are looking not only at galaxies, but at the quiet truths of your own life. Storms come, yes. They change what they touch, they scatter, they ignite, they reshape. But afterward, always, there is calm. And in that calm you find a new wholeness, not the same as before, not unchanged, but still beautiful, still enduring. So the fate of colliding galaxies is not only drama and fire, but also rest. It is not only the birth of stars, but also the long twilight of old ones. It is not only the merging of black holes, but the quiet glow of a settled core. And you, carried on the currents of this story, find yourself breathing more slowly, as though the calm of galaxies has touched you too. You realize that, like them, you are not diminished by change. You are shaped by it. You carry it. And in the stillness afterward, you are more whole than before.
The calm within a merged galaxy is only part of the story, because galaxies are not islands in isolation. They are members of families, clusters, groups, even vast superclusters that stretch across cosmic filaments. When one collision unfolds, its echoes travel outward, tugging on the surrounding neighborhood in ways both subtle and immense. Picture the local group, your own corner of the universe, the Milky Way, the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller companions all bound together by gravity. They drift as one, carried along a filament of dark matter, orbiting slowly in a long cosmic dance. The collision of the Milky Way and Andromeda will not simply reshape two galaxies, it will reverberate through the local group itself. Stars flung outward during the merger may stream into intergalactic space, adding to the faint halos of light that surround the cluster. Gas heated by black hole outbursts may spill beyond the borders, stirring the thin medium between galaxies. Like ripples from a stone dropped into a pond, the effects reach farther than you might expect. Now imagine standing, if standing is the right word, on the edge of a cluster far larger than your own. The Virgo cluster, for instance, home to over 1,000 galaxies. Here, collisions are not rare events spread across eons, they are the very heartbeat of the cluster. Galaxies dive through the dense environment, tugged and twisted by the gravity of their neighbors. Some fall into the core and are stripped bare, their gas pulled away like mist in a storm. Others merge, forming giant ellipticals that dominate the cluster's heart. In such environments, collisions sculpt not just individual galaxies, but the architecture of the cluster itself. Each new merger alters the balance, redistributes mass, and changes the gravitational tides that bind the whole. And then there are superclusters, webs of galaxies stretching hundreds of millions of light-years. Here the picture becomes stranger still. The great cosmic web, built of filaments and voids, carries galaxies like leaves on rivers. Collisions along these filaments ripple outward, changing the flow of matter along vast scales. It is hard to imagine, from a human perspective, what such a structure feels like. A single galaxy already dwarfs comprehension, containing billions of stars. A cluster holds thousands of galaxies, their light smeared across the sky. But a supercluster? It is not even a single object, but a pattern of patterns, a rhythm of gravity stretched across eternity. And yet, even here, the quiet truth remains: collisions matter. They guide how galaxies feed, how clusters grow, how the web itself evolves. There is an eerie detail that astronomers have discovered when mapping these great webs. Some galaxies are not only flung outward, they escape entirely. During violent interactions, a few stars or even whole galaxies can be hurled at such speeds that they break free from their cluster, drifting alone into the deep voids between filaments. Runaway galaxies, solitary travelers in the dark, their lights dimming with no neighbors to share the silence. It is a haunting thought. Entire galaxies, each filled with stars and perhaps worlds, exiled into the black. No cluster, no group, no companions. Just endless night with only the faintest glimmer of distant structures on the horizon. Researchers still debate how many of these solitary wanderers exist and whether they play a hidden role in the larger story of the cosmos. But not all the ripples are destructive. Some are creative, weaving new patterns of cooperation across space. Streams of stars, torn from one galaxy, may be captured by another, knitting bridges of light across the cluster. Gas expelled from collisions enriches the intergalactic medium, seeding future generations of stars with heavier elements forged in past lives. Even the radiation from merging black holes may help regulate the heating and cooling of the space between galaxies, balancing growth and rest. The neighborhood changes, yes, but it is never still. The ripples never fade entirely. They move outward, across light years, across epochs, across the very fabric of the universe. As you drift through these scales in your mind, you may feel both small and strangely at home. Your body is made of atoms born in such processes: carbon, oxygen, iron, all forged in stars that may themselves have been sparked by ancient collisions. The ripples that pass through clusters and superclusters are the same ripples that seeded the elements of your blood, your bones, your breath. You are not separate from these neighborhoods. You are one of their quieter voices, a brief echo of their longer song. Researchers still wonder how collisions across clusters shape the universe on its largest scales. Are superclusters truly bound, or are they temporary gatherings, destined to thin out as the cosmos expands? Will the ripples of collisions keep shaping matter, or will the accelerating expansion one day drown them out, pulling galaxies apart faster than gravity combined them? These are questions without answers, yet. The universe is still unfolding, and you are living in one of its in-between chapters, a chapter where galaxies collide, clusters ripple, and superclusters drift, all while a fragile species on a small blue world looks up and wonders. So the calm of a merged galaxy does not end the story. It simply begins a wider one. Because galaxies are never alone. They live in neighborhoods, and those neighborhoods in cities, and those cities in webs that span the dark. And when one of them collides, the ripples travel outward, brushing against you in ways you cannot see, but can almost feel, like the faintest shiver of wind against your skin.
There comes a strange realization when you step back and consider what happens as two galaxies merge. Despite the violence, despite the distortions of gravity and the storms of radiation, what emerges is not only chaos, it is music. Not the kind of music you hear with your ears, but a symphony woven into the very fabric of space-time. Every star tugged off course, every orbit stretched and broken, every wave of gravitational energy radiating outward, all of these are like notes, plucked and resonating in a cathedral without walls, without ceiling, without end. If you could somehow listen with senses tuned to the deep vibrations of the cosmos, you would hear it, a performance lasting hundreds of millions of years. Imagine you are sitting in an orchestra, not a human-sized one, but an orchestra on the scale of light years. Two colossal players, the galaxies themselves, approach the stage. They do not hold violins or pianos. Instead, they bring their entire structures, stars, nebulae, black holes, spirals of dust. At first, the music is soft, a faint hum. The outer stars circle cautiously, producing delicate tapping like a hand brushing lightly across piano keys. Then, as the cores drift closer, the tempo rises. Orbits twist into spirals, gas clouds crash together. The melody sharpens like taut strings under a bow. Finally, the crescendo, two galactic centers rush together, their supermassive black holes spiraling into a union. The sound is the loudest drumbeat imaginable, echoing not through air, but through the lattice of reality itself. With instruments like LIGO, or even more advanced detectors in the future, we can already listen to some of this cosmic music. Gravitational waves are ripples, rhythmic and ordered. Scientists often translate them into audio. When two black holes merge, the sound is a short, rising chirp, a brief note swelling and vanishing. But the merging of two entire galaxies would be different. Not a chirp, but a symphony so low, so stretched out in time that no human ear could hear it directly. It would be more like the vibration of the earth beneath your feet, a deep hum below the threshold of awareness. Yet it is there, constant, flowing, real. And inside this orchestra, there are solos, motifs, flourishes. A lone star flung outward, exiled into intergalactic space, becomes a single, long, fading note. A star cluster plowing into a dense molecular cloud lights up with supernovae, sudden trumpet blasts that echo, flare, and die. A fragile planet loses its orbit and falls into the furnace of its star, a sharp, dissonant chord gone in an instant. Up close, this might seem chaotic, but from afar, all the fragments blend into a grand design. Like a mosaic seen too near, you see only broken shards.
Step back, and the picture appears, coherent and beautiful. The universe excels at this, turning local disorder into cosmic symmetry. If there were a civilization long-lived enough to watch the entire performance unfold, they might pass it down as legend. Each generation would hear only a fragment of the song. The elders would tell the young, "We lived through the beginning, when the first notes trembled." Their children would say, "We live now, in the middle movements." And their descendants would one day whisper, "The ending is near, the last chords are playing." Across millions of years, a single story is told, not through words, but through light and gravity. So how does the music end? Not suddenly. There is no silence crashing down. Instead, it fades. The stars settle into new orbits, the dust disperses. The black holes merge and calm. The new galaxy, often a smooth, elliptical giant, emerges as the final chord, long and low, sustained into the future. It resonates in the dark like the echo of a gong struck once, reverberating long after the strike is forgotten. And you, the imaginary witness, sit there in the void. There is no applause, no crowd, only you and the vastness. And in that quiet, you realize something profound. You were present for one movement of the universe's greatest symphony. Your lifespan is but a blink compared to the length of the piece, but you heard it nonetheless. And perhaps that is enough. The galaxies may forget themselves, blending into something new. Stars may flare and fade, but the music continues, in ways beyond your comprehension, in rhythms older than life. The final symphony of galaxies is not an end. It is simply a transformation of melody, from spiral to ellipse, from chaos to calm. And the universe continues to hum its endless song.
You've wandered with me through an immense story. Two galaxies that began as strangers have moved closer, entwined, collided, and finally merged into something new. You've watched tidal tails stretch across the night, black holes spiral into each other, and bursts of new stars light up the darkness. You've stood still while the universe reshaped itself around you, each step slow, each movement patient. And now, as you drift deeper into this quiet narration, the final chapter begins. It is not a loud ending, not a sudden snap. Instead, it is like watching waves soften after a storm. The galaxies that were once two are now one. Their shapes, once distinct, have blurred into a single smooth outline. Where there were once spirals and chaotic bridges of stars, there is now a vast elliptical glow. The last notes of the symphony linger in the stillness, and then fade. If you picture yourself hovering far above it all, you see the new galaxy shining steadily. Its heart is calm, its black hole unified. Its arms, once distorted and tangled, have dissolved into a rounder, softer halo. This is the fate of many galaxies in the universe. Mergers turn them from spirals into ellipticals, from whirlpools into oceans. The transformation is slow but certain, written into the mathematics of gravity itself. Here is a quietly fascinating fact. Our own Milky Way is already on a path towards such a union. In about 4 billion years, it will meet the Andromeda galaxy. They will merge, just as we've imagined. If life still exists here then, some distant descendant of ours may look up and see the night sky filled with strange arcs of light, whole swaths of stars where once there were only dark spaces. For them, the story you've drifted through tonight will not be theory. It will be home. And yet, there is an eerie detail hidden even in this reassurance.
After countless billions of years, after galaxies merge and stars are born and die, the universe itself grows dimmer. Star formation will eventually decline. Elliptical galaxies, though grand, are quieter. Their gas is used up, their birth slow. The night sky of the far future may not blaze with starbursts, but glow faintly, with the soft persistence of aging suns. Researchers still debate the exact timeline, but they agree. The universe is not in a rush. Even endings stretch into trillions of years. But as you think of this, perhaps there is comfort. The cosmos does not waste what it has made. Even in decline, stars burn, planets circle, life may still look upward and wonder. Galaxies may merge, but memory of their light is carried forward in every photon, every wave, every gravitational ripple. Nothing is truly lost, it simply changes form, like notes lingering in the air after a song ends. And so, you let yourself drift. You feel the last vibrations of the galactic symphony pass through you, fading but never fully gone. You imagine lying on your back in some quiet field, watching not fireflies or clouds, but galaxies colliding in slow motion. You know you cannot live long enough to see their end, but you have lived long enough to imagine it. And sometimes, imagination is the closest bridge we have to eternity. Your breath slows. Your thoughts soften. The story has not rushed, and neither should you. Just as galaxies take millions of years to merge, you are allowed to take your time, to let go, to dissolve into rest. You probably won't survive this world unchanged, but that was never the point. The point was to float, to see, to feel. That's all for tonight. Let your mind keep floating, or drift into sleep. I'll be here again next time.